What's up, guys? Today we are going to go over geometric sequences. Last time we did arithmetic, so today we'll do geometric. And then we only have two more lessons after this from this chapter. So, find the fifth term in each of these number patterns. Can you tell what these sequences have in common? Explain your reasoning. Well, it looks like the first one, 3, 6, 12, 24. You can see that it's doubling, so double that. B looks like it's adding one more zero after the decimal. So the next one would have 4 zeros after the decimal. And this one goes from 1/3 to 1/9, or negative 1/9 to 1/27 to negative 1/81. So the bottom is multiplying by 3, and it's alternating signs. So maybe like 1/243 or something like that. So those are all geometric sequences because the ratio of any of its terms to its preceding term is a constant value, meaning you're multiplying by the same thing every time. Geometric sequence has a starting value a and a common ratio r. So it looks like this if you were to write it out in that form, a and r. You have your recursive definition, which also always has two parts, just like the arithmetic one. The first is you say what your first term is, so a1 equals a, whatever that is. In the next part, you say an equals an minus 1, which is the previous term, times your ratio r. So you just plug in r for that one. So you're just plugging in a and r, and everything else stays the same. For the explicit definition, we just use a single formula, which is an equals first term, a1, times r to the n minus 1. And n has to be greater than or equal to 1, so no negatives. Alright, is this geometric? If so, what is a1 and r? This was the same as the first problem we did. So a looks like you go 3, 6, 12, 24, so it is doubling, so it is geometric. So a1 would be your first term, which is 3. R would be your ratio, which you're multiplying by 2, so it's just 2. 3, 6, 9, 12, 15. Now this one is just adding 3. So this one's actually arithmetic. So this one you could say your first term is 3, and your common difference, not ratio, is 3. But that's not geometric. That was an arithmetic. This one you can see that the 3's are staying the same, but you're adding the exponents. But when you're adding the exponents, really what you're doing is multiplying by 3 to the 5th, because this is going to equal 3 to the 10th. Oops. And then if you multiply that by 3 to the 5th again, you add the exponent, so 3 to the 15th. So this one actually is geometric. The first term is 3 to the 5th. Your ratio is actually also going to be 3 to the 5th, because every time you add 5 to the exponent, what you're really doing is multiplying by 3 to the 5th power. Stop. Okay. Find the 10th term in the sequence. Okay, to do this, you probably want to write out the formula for this, so you don't have to write out 10 different things out. So you'd say an equals your first term, which is 4 times r, which in this case you're multiplying by 3, so times 3 to the n minus 1. So then you just want the 10th term, so you just plug in 10 for n, which would be 10 minus 1, which is 9. And I don't want to figure out what that is, but it would come out to be 4 times 3 to the 9th. Find the second and third terms of the geometric sequence. Okay. So looking back, we have our first term a, which equals 2. Then a times r, which we don't know, it's question mark. Then a times r squared, which we also don't know, so it's another question mark. But we do know the fourth term, which is going to be a times r cubed. And actually we know what a is, so we should actually put in 2 for that. And then we can solve for r. So then we just divide by 2, so we get r cubed equals negative 27. Then cube root that, so we get r equals negative 3. So that tells you your ratio, which means then we can plug that into these. Or you can just multiply your terms by negative 3. So the next term, if we're multiplying by negative 3, would be negative 6 times negative 3 is positive 18. Whenever your ratio is negative, it's always going to alternate signs between positive and negative. So negative 6, positive 18, negative 54, positive 162 or something. Okay. Okay, when a ball bounces, the heights of consecutive bounces form a geometric sequence. What are the heights of the fourth and fifth bounce? Okay, so we have 100, we have an unknown here, we have 49. So first thing we could do is figure out what the ratio is, again, by doing, we can use this as A. This would be A times R, this would be A times R squared. So I know that 49 equals 100 times your ratio squared. So we just divide, so we get 49 over 100 equals R squared. Square root that, and we R equals 7/10. So that's going to be our ratio. So if we want the fourth and fifth, well, we already have the third here, it's 49. So to find the fourth, we can just multiply 49 by 7/10. So 49 times 7/10. It's going to come out to be something. And then to get the fifth one, we would just do 49 times 7/10 squared, because that would be the fourth term here. This would be the fifth term. And every other term you just keep multiplying by 7/10. Alright, last thing. So last time we talked about an arithmetic mean, which is basically the mean that we all think of. You just add them up and divide by however many numbers there are. But we also have a geometric mean. And the geometric mean of two positive numbers, x and y, is going to be the square root of x times y. So the way that you can kind of remember that is it's just 1 degree above everything. So like arithmetic, you are adding or subtracting. Geometric, you are multiplying or dividing. So it's kind of arithmetic, or geometric is 1 degree higher than arithmetic. So when you think about the arithmetic mean, you're doing x plus y divided by 2. And if you take each of those operations, the plus and the divide, and you raise them up a level, I guess, it would become x times y, because plus would go to times. And then when you're dividing by 2, a level above that would be an exponent or a radical, and since it's division, it's going to be a radical, so you'd square root it. So that's how you get the geometric mean, square root of x, y. Note the geometric mean is positive by definition, while there are two possible values for the missing term in the geometric sequence, 3 blank 12, because it could be positive or negative there. There's only one geometric mean. The geometric mean is one possible value to fill in the geometric sequence. The opposite of the geometric mean is the other. So that's why on this one we have all these plus or minuses. It says what are the possible values for the term of the geometric sequence. So all you have to do here is take the square root of 48 times 3. 48 times 3 is what? And 48 times 3 is 144, so square root of 144, we have to get plus or minus 12. So it could go 48, 12, 3, and say that you're dividing by 4, or it could go 48, negative 12, 3, and then you're dividing by negative 4. But it's impossible to know with the given information, so you have to answer both. Alright, and I think that's it. So that was nice and quick. Alright, I'll see y'all later. Be good, be safe. May the 4th be with you.